In 5.3, we are going to be working through linear models, which is essentially the section where we are going to be writing equations from word problems to figure out the equation that's going to represent the situation that's happening. So we are going to start this with an example where we have a large fish pond is filled to capacity and holds 1,300 gallons. And we're also told that the pond is being drained at a rate of 10 gallons per minute. And now we want to use this information that we have to write a linear model that's going to tell us the amount of water remaining in the pond. We can do this by saying that the gallons of water is equal to our rate of draining being multiplied by the number of minutes that have gone by, and then adding on the initial quantity of water that we have. So let's give some variables for what these are. We have our gallons of water. I'm going to call that G. So the number of gallons of water that are in the pond, this is going to be equal to, well, our rate of draining. We have it's being drained at 10 gallons, but I don't want a positive 10. I want a negative 10 because we're taking away 10 gallons every minute that goes by. And then I need to multiply this by our number of minutes. Well, I'm just going to call the number of minutes X. And then we need to add on our initial amount of water, which is 1,300. So we have an equation that says G is equal to negative 10x plus 1,300. And now with this, the next step, I want to find our x and g intercepts. This is what we had done at the end of 5.2. And I'm going to start off to find the g intercept. So to do that, all I need to do in my equation is let the other variable be 0. So we're going to replace x in our equation with 0. So we have g equal to negative 10 times 0 plus 1,300. And that just gives us that g is then equal to 1,300. And a lot of times with our intercepts, we prefer to write them as ordered pairs. So this g-intercept is going to have an ordered pair of 0, 1,300. Next, I'm going to find our x-intercept. And to do that, we can let the other variable g be 0 in our equation. So we have 0 equal to negative 10x plus 1,300. And now we need to solve this equation here for x. So to do this, I'm going to add 10x to the other side, so that everything with an x on it is on one side, and then everything without an x is on the other. So we have 10x is equal to 1,300. And now we can divide both sides of our equation by 10. So this is going to give us that x is equal to 130. And now once again, we like ordered pairs for our intercepts. So we can say that the ordered pair for the x-intercept is 130, 0, because we put in 0 for g. So now let's interpret what these mean. This is where the ordered pairs play nicely in interpreting what these are, because remember, our ordered pairs are x, g for this. So for this g-intercept, this tells us that at 0 minutes, because our x is minutes, there was 1,300 gallons in the pond. We could also say something like at the beginning or before they started, sort of implying the 0 minutes part, that there was then 1,300 gallons of water in the pond. The next one for the x-intercept, we have an ordered pair of 130, 0. So with that, we could say after 130 minutes, there was 0 gallons of water in the pond. We could also, instead of saying 0 gallons of water, we might say something like the pond is empty. There's no more water left. So now, in this example that we had for our gallons of water in the fish pond, we were given what B, our y-intercept is. That was our initial value, the 1,300. We were also given the slope. That was the rate that we saw, where it's the negative 10 gallons per minute. That makes it easy to write the equation, because when we have our y equals mx plus b, the two things that we need to be able to write the equation are m and b. A lot of the times we're not going to have exactly that information, but we might be given other stuff. So to write a linear model, we need to figure out, do we have the correct information to be able to write it, and where do I go from there with the information that we have? So there's sort of 3 different types of setups that you might have when wanting to write the equation. The information that you might have, if we start with the first one here, this is what we just did, where you're given the slope and you're given the vertical intercept, the y-intercept. That's just directly m and b, and you can write your equation. The next option is a little bit more work, but not too bad. You're still given the slope of the line in the equation. You're given some sort of rate, but then you're given a different point on the line, something that's not the y-intercept. And then with that, what you need to do is essentially use that point as your x and y in your equation and be able to solve the value b. We'll do that in the next example in the next video. And then the last problem type of information that you might have is where you are just given 2 points, x1, y1, x2, y2. And with that, you need to first find your slope using our equation for slope, and then you can find what b is with the process of the last one that we'll do.